In this video, we'll cover the following topics related to laser safety. Preparation upon entering the lab, planning the laser experiment, discussing your plan with your supervisor, assessing hazards, reducing hazards, identify and understanding the optical components, building engineering controls, making the beam horizontal, inserting a new optical object in the beam, aligning the lens, mirrors and prisms, blocking stray beams, relative sensitivity of the eye to different colors. So, let's get started. The first thing that needs to be done is preparation upon entering the lab. Upon entering the lab, remove all reflective objects from your body. The next step is setting off the laser experiment. You'll need to create a sketch of the experiment, such as that shown here. When setting up your laser experiment, make sure that the laser does not point towards the door. Also, the rules is that laser should never leave the optical table, should always be horizontal at a height that is not close to your eye. Next, you'll need to discuss your plan with the laser supervisor, your professor, or a more experienced colleague. Make a hazard assessment before you start. Identify all the hazards and all the people that need to be in the room. Reduce the hazards by eliminating unnecessary objects and people during the work and by implementing the controls. To ensure that the laser does not leave the optical table, you will need to block the beam when you don't need it. So for that, I build a tube through which the beam passes here. When the beam makes 90-degree angle, I block the beam, then the beam will pass through these irises and will reach this end of the table. You need to block the beam here. If you put a mirror here and the beam will go to the other end of the table, you need to block the beam there also. The most dangerous beams are oblique and vertical beams. Here I build a periscope with two mirrors, and because the beam, it's possible to miss the second mirror and come up, you have to block the beam. During the experimental work, you will need to stop the beam. So I built these beam stoppers from plastic because the power of the beam is so low, you don't need to make them metal. But if you are using high power lasers, they will be made of metal. In this experiment, the power is kept low, so we don't need a laser gun. Yeah, you're getting there. Yeah, it's good. Okay, now we will insert an optical object in the beam. For that, you need to block the beam first. Unblock the beam. And now let's try to align the beam. With the lens, you will have two stray beams. One should be on one side of the iris and the other stray beam should be on the other side of the iris. Now the lens is aligned. Now the student will insert an optical object with flat surfaces in the beam. She pays attention to the main beam, but in the same time the stray beams are going back and they can reach your body. Therefore, you need to block the stray beams. We're gonna show the sensitivity of the eye. Even though the lasers have similar power, the green, you can see it's very bright. Now if we start the red and put them one near another, we can see that the red is not as bright as the green, and we will move to the near infrared 780 nanometers, and you will see the beam very faint, and in farther infrared the beam cannot see it at all with the normal card. To see the beam you will need infrared card.